Hello students, in today's session of NCERT chapter Wave Optics, very basics on the topic of interference will be cleared through illustrations taken from NCERT exercise also. NCERT exercise also. In today's session, we are going to discuss what is interference, what is constructive, what is destructive, what is the relation between part difference, phase difference, and time. To find nth dark fringe, to find nth bright fringe, to find beta fringe, etc. and other number of points will be cleared through this session. It is requested to go through the session completely. Now let's start with the question and concepts. Question is, the ratio of maximum to minimum intensity due to superposition of two waves is 49/9. Then the ratio of intensity to component waves is, four options are given to you, one of the options is correct. Concept applicable and solution. In this case, it is a case of superposition of two waves. First, before I start with the question, I will discuss certain concepts. When two waves are superposed having amplitude A1, A2 and constant phase difference phi, generated amplitude is given by this formula and direction of the amplitude is this one. Now, as the intensity of wave is given by half rho omega square A square V square. Rho is the density of the medium in which the wave travels. Angular frequency, A amplitude of the wave, V is the velocity of propagation, velocity of wave. Right? If this are constant, then amplitude, intensity is proportional to amplitude square. In that case, resultant intensity can be written as this formula. Resultant intensity can be written as by this formula. In this case, the term this is called interference pattern. And from this we can find when will the constructive interference, when will the destructive interference. If cos phi remains constant with time, the total intensity endpoint will be constant. Intensity will be maximum if cos phi is 1, that is under root I1 plus under I2 whole square at the point where cos phi is 1. Intensity will be minimum I1 minus root I2 at point when cos phi is minus 1. Right? Now let's start with the question. Now let's start the question. According to question, I maximum or I minimum is given to you 49/9. To find क्या करना हमने I1 over I2 to determine. Now, as intensity proportional to A square, therefore, I maximum upon I minimum will be equal to I maximum A1 plus A2, A1 minus A2 whole square, or you can say root I1 plus root I2 upon root I1 minus root I2 whole square. Right? Now, that can be written as root I1 upon I2 plus 1 upon root I1 upon I2 minus 1 whole square. That is I maximum upon I minimum. Let I1 over I2 equal to x. Then I maximum or I minimum equal to x under root x plus 1 upon under root x minus 1 whole square. Substituting values. I maximum upon I is 49 by 9. 49 by 9 equal to root x plus 1 over root x minus 1 whole square. Root x plus 1 upon root x minus 1 equal to 7 by 3. Then by C and D, compound dividend. This comes out to be root x plus 1 plus root x minus 1 upon root x plus 1 minus root x plus 1 equal to 7 plus 3, 7 minus 3. Right? On simplification, this comes out to be this goes, this goes, sorry, this goes, this is so root x upon 1. 2 cut jayega, that is 10 upon 4, that is 5 by 2. Therefore, x equal to 25 by 4. X square I1 over I2. The answer is, let's see the answer. Answer is option A. Option A is correct option. Option A is correct answer. Right? Next question. Question is, two coherent sources of intensity ratio beta square interfere. Then the value of I maximum minus I minimum divided by I maximum plus I minimum is, 4 options are given to you, one of the options is correct. Concept applicable and solution. You know, if two waves interfere, superpose, then the resultant amplitude is given by A1 square plus A2 square twice A1 A2 cos phi. Phi is the phase difference between the two waves. That should be constant. As the intensity of wave is given by I equal to 1 by 2 rho. Rho is the density of the medium in which the wave propagates. Omega is the angular frequency, A is the amplitude of the wave, V is the velocity of the wave. If these parameters are constant for a given wave, for this and this, then intensity is proportional to amplitude square. Then this can be reduced as I equal to I1 plus I2 plus 2 under root I1 I2 cos phi. This term is known as interference term. Interference term. Now, I maximum will be when cos phi equal to 1. That is I1 plus I2 plus 2 root I1 I2 into 1. That comes out to be I maximum equal to I1 root I1 plus root I2 whole square. I minimum, similarly, cos phi equal to minus 1 and I minimum will be equal to root I1 minus root I2 equal to whole square. Now, as I1 over I2 according to question beta square by 1. Therefore, I maximum upon I minimum can be written as, this can be written as this is beta square by 1, so I maximum or I minimum will be root I1 plus root I2 whole square upon root I1 minus root I2 whole square, right? Then I maximum upon I minimum will be equal to root I2 common लिया तो root I1 over root I2, I1 over I2 plus 1 whole square root I1 over I2 minus 1 whole square. That can be written as root I1 over I2 will be under beta square by 1, that is beta. So that is 1 plus beta whole square over 1 minus beta whole square. We want to find it out 1 plus I minimum over I maximum minus I minimum upon I maximum plus I minimum. That can be written as 1 plus beta whole square minus 1 minus beta whole square divided by 1 plus beta whole square plus 1 plus beta whole square. इसको सिंप्लीफाई कर देते हैं 1 plus beta square plus 2 beta minus 1 plus beta square minus 2 beta upon 1 plus beta square plus 2 beta plus 1 plus beta square minus 2 beta. On simplification, this goes 4 beta upon this goes 2 taken common 1 plus beta square, that is 2 beta upon 1 plus beta square. This is the answer. Let's check the answer. Answer is this is not, this is not, this is not. Means none of the above. None of the above. D is the correct option. D is correct option. Right. Next question. Question is, two coherent sources A and B of radio waves 5 meters apart. Each source emits waves with wavelength 6 meters. Consider the points along the line between the two sources at what distances, if any, from A is the interference constructive and destructive. Concept applicable and solution. You know resultant intensity I1 plus I2 plus 2 root I1 I2 cos of phi. IR will be I maximum if phi equal to 0, 2 pi like this, right? That is 2 and pi. That will come out to be for constructive interference. IR will be I minimum if phi equal to pi 3 pi like destructive. ये लेंगे तो cos phi minus 1 आ जाएगा, ये लेंगे तो cos phi 1 आ जाएगा. If cos phi is 1, then the constructive. If cos phi is minus 1, then the destructive. You know the relation. T corresponds to 2 pi corresponds to lambda. Time taken to complete one oscillation, time period. This angle traveled 2 pi, distance traveled lambda, right? Then part difference equal to lambda upon 2 pi into phi. This is the relation. Then for constructive, phi should be equal to 0, part difference 0, that is at the center. Constructive. एक पॉइंट ये एक पॉइंट बी है, ये सेंटर है. point P. This is center 2.5. This is the 2.5 meter, 2.5 meter, right? For destructive interference, phi should be equal to 180 degree. Then that is part difference should be equal to lambda upon 2 pi into pi. That is lambda by 2. First जो है उसका multiple आते जाएंगे और multiple of lambda by 2. That comes out to be, this comes out to 6 divided by 2, 3 meter. This is A, this is B, P1. So this is total distance is 5 meter. So this is lambda by 2 is 3 meter. If 3 meter, then this is 2 meter. One of the possibilities, this is A, this is B, this is P2. This is 3 meter, this is 2 meter. In this case, part difference is BP1 minus AP1 equal to 3 meter. In this case, AP2 minus BP1, BP2 equal to 3 meter. That is the condition of constructive interference. Right? There are two cases. Right? Next question. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very, very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video of sessions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question. Question is, in Young's double slit experiment, the slits are separated by 0.28 mm and the screen is 1.4 meter away. The distance between the central bright fringe and the fourth bright fringe is 1.2 centimeter. Determine the wavelength of the light used in the experiment. Concept, applicability and solution. This question has been taken from NCERT Access. What is Young's double slit experiment? It demonstrated the phenomenon of interference of light. The setup is this one. Two coherent sources. Two coherent sources move, interfere, meet at a point P from center. The capital D is the distance between the sources and the slit, and the Y is the position of maxima or minima. Right? Part difference is given by, part difference means one wave is this at point P, one wave is at this point P. The distance between these two is the part difference. That is equal to Y by D. Now, for constructive interference, what is the condition? Distance of the nth bright fringe from O is this one. 0, 1, 2, 3. 0 means central. Right? For destructive interferences, this is 2n minus 1 d lambda by d. This is 1, 2, 3. First, second, third, right? Then these 2 points are applicable here. And fringe width is d lambda by d. What is capital D? What is lambda? That d is the wavelength of a monochromatic light, right? Used. Now further to discuss fringe pattern. This is the fringe pattern. Center is always the maxima. Then the bright point will be obtained. Then first D1, B1, D2, B2 like this. Similar on the upper end, on the downside, upside. Right? Distance between two conjugate dark or two conjugate is the fringe width beta. Fringe width. This is the distance D. This is distance between source and slit. Now according to question, D is given to you 0.28 mm, means 0.28 into 10 raised to the power minus 3 meter, right? Then skin is capital D is 1.4 meter. The distance between the central bright fringe and the D4 means you have to find B0 and B4 के बीच की distance चाहिए, Y4 चाहिए. You know, distance of bright fringe is equal to n. ये आपको दिखा दिया था. N d lambda upon d. And d lambda upon small d. So substituting the values, you have to find this. We have to find the wavelength of this. Y is given to 4, 1.4. Y4 is given to 1.2 into 10 to the minus 2 meter. Be very, very careful. Units should be same, either meter, either centimeter or mm. Substituting values, we get lambda comes out to be 6 into 10 to the minus 7 meter. This question was orally, we can do directly formula, but to clear the concepts, clear the impression, what we are going to do is I have cleared here. Right? Next question. Question is, in Young double slit experiment, using monochromatic light of wavelength lambda, the intensity light at point the skin where part difference is lambda is k units. What is the intensity of light at a point where part difference is lambda by 3? You have to find the intensity in terms of k. Young double slit experiment. This is a Young double slit experiment. Two sources, coherent sources. Having same wavelength, same amplitude, superpose here. Then depending on the part difference, dark or bright fringes will be obtained. Right? For constructive interference, this is the condition. For destructive interference, this is the condition. Y equal to, Y is the distance from center, right? That is equal to d lambda upon d. 2n for constructive, 2n minus 1 d lambda by d. Fringe width d lambda by small d. Now, you know IR given as I1 plus I2 plus root 2 I1 I2 cos phi. Now, as I1 equal to I2 equal to say I, right? And initial part difference is lambda. You know, T corresponds to 2 pi corresponds to lambda. That is path difference equal to lambda upon 2 pi into phase difference, right? So path difference is initially, path difference is lambda means phi is equal to 0. In that case, IR will be equal to I plus 2 under root I into cos 0. That is I plus 2i, that is 4i. Intensity is corresponding to 4i is this one, K. This is now to find IR when part difference is lambda by 3. Part difference is lambda by 3, that is equal to lambda upon 2 pi into phi. Phi comes out to be 2 pi by 3. 2 pi by 3, that is 120 degree. Cos of 120 degree is cos of 180 minus 60, that is minus 1 by 2. Therefore, IR will be comes out to be I plus 2i into minus 1 by 2. That is I. Now, I equal to क्या है यहाँ पे? I is equal to K by 4. So, resultant intensity will be K by 4. This is the answer. Intensity corresponding to path difference lambda by 3. Intensity will be K by 4. Right? Next question. A beam of light consists of two wavelengths, 650 nanometer and 520 nanometer, is used to obtain interference fringes in a young double-slit experiment. Find the distance of third bright fringe on the scheme from the central maximum for wavelength 650. What is the least distance from the central maximum where bright fringes coincide to the both the wavelengths? Where bright fringes to both the wavelengths coincides. Concept applicable in solution. Questions taken from NCERT back exercise. Right? Concept applicable for constructive bright. Distance from central bright fringes and d lambda upon d. We have to find third. We have to find the third bright fringe. N equal to 3. So y3 will be equal to 3d lambda upon d. D की वैल्यू लैम्डा की वैल्यू पुट कर दी, दैट इज 650 नैनोमीटर. 650 ये नैनोमीटर. सॉल्व कर ली जो भी करना, दैट इज आंसर. सेकंड पार्ट है व्हाट इज द लीस्ट डिस्टेंस ऑफ सेंट्रल मैक्सिमम वेयर ब्राइट फ्रिंजेस. ये क्या होता है? दिस इज द सेंट्रल. D1 B1 D2 B2 similarly here, right? So we have to take N1 lambda 1 equal to N2 lambda 2. For least distance, suppose this is the 650 is the greater wavelength. Then N1 will be equal to N1 is N, so N2 will be N minus 1. So substituting values, N1, N into smaller wavelength, small wavelength is 520, equal to N minus 1 into 650. इससे सिंप्लीफाई करके जो भी आ जाएगा दैट विल बी द फाइंड एन. नंबर पता चल गया. उसके बाद ब्राइट फ्रिंज की डिस्टेंस ले लीजिए. y विल बी इक्वल टू n dy and d lambda upon small d. Put it here. That will be the answer. Right? Now I would like to request, if you are new to my YouTube channel Sethiswiftlearn, Please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.